So this video log is about frame rates and what I've come across generating levels procedurally. Thought I'd just go over an experiment that I was working on, just trying to figure out how to keep a steady frame rate while doing a lot of overhead processing. So if you look over on the right, you're going to see what you would write normally in terms of generating 1,000 different objects at once. I've also, in that behavior, I've created some code that just taxes the CPU a little bit. I can show that to you right now. So basically every time a ball is instantiated, it's going to run through a loop 200 times and set the position. Obviously, that's not something you'd want to do under normal circumstances. However, I'm trying to create lag. So if you take a look on the game view, you're going to see every 5 seconds or so, it's going to stutter. It's going to stop, and then it's going to lurch. It's going to lurch because the spiral is going to catch up. And since the rotation is set to a delta time, it's going to catch up to where it should be. So really the best option is just to avoid that lurch altogether. And let's stop this and head over to the script that's running. The spiral is in the update, so every update that spiral is going to rotate, and on the instantiation of those 1,000 balls, obviously you're going to see that rate drop. Start's going to call spawn, and spawn's going to run that instantiation every 5 seconds. Below that, you get two methods here. You got create stuff and create stuff coroutine. What I'm running now with the lag is create stuff. So this is straightforward. First, clean everything up, because every object goes into a container. So just clear out that container, and then run through and create the ball with this behavior attached with the CPU overhead. And if we run it again and watch our CPU usage, you'll see that every 5 seconds it's going to lurch, and you'll see a huge spike. That spike's going to show something like 200 plus milliseconds. That's just the CPU thread. That's just the main CPU thread basically freezing, because it is not able to animate anything on a frame basis until this entire method goes through and completes. So the alternative is to use a coroutine. I haven't exactly hashed out the best way to do this yet, but I can show you that it is possible to get rid of that that frame drop just by comment that out and use the coroutine version. So now when we run it, let's wait for the generation here. And there shouldn't be any lag anymore. If you look at the CPU usage, it is stretching out all that processing over many frames. This isn't all upside. This makes things a little bit more complicated, but it's not terribly complicated either. You just look at the profiler and you can see that this is going to be a lot better experience for someone that's interfacing with this. So let's take a look at the coroutine. So rather than doing all this at once, we're going to start a coroutine. And so here's the clearing out. What's going on here is every time 20 objects are destroyed, we're going to yield, and that's going to hand back control to the main thread so that it can continue to do frame updates. Once it updates the frame, basically we've just paused this method. So it's going to come back here. It's going to continue the for each. And when we're finally done, we're going to yield again. Then we're going to go into generation. Every 10 balls that are generated, again, we're going to hit the pause button, let the main thread update, and then continue on. So it's possible to create bugs this way. So if you have another object on this scene and that object expects everything to be created at once, well, that's not happening. So if you go this route, you have to think in those terms that some of these methods are going to run over frames. As long as you don't have incorrect expectations, you'll be okay. If you think it's worth it to not have frame dropouts, then this is one way you can go about it. So anyway, that's all I got. And hopefully I'll bring some of this back into the game in my procedural level generation. If you have better ideas about how to achieve this, leave a comment, and see you later.